Please welcome to the stage Patricia Florissi, Chief Technology Officer, Global Sales at Dell.
Good morning, everyone. It's a pleasure to be here today. Before you actually get confused with where my accent comes from, I'm originally from Brazil. My mother tongue is Portuguese. The Italian last name, like everything else in my life, is my husband's fault, and I can prove that. I want to thank you for taking the time to be here today as we are in the dawn of a new era, the dawn of the digital era. And this era, this future, is going to be bound by many technology forces. And today we are going to look at just but some of them. If you look at artificial intelligence, you actually realize that computer science is going to be celebrating 100 years very, very, very soon, and it went like a snap. In the 1950s, computer science branched on into artificial intelligence. Now, there was no word of learning there. It was not artificial learning, no learning intelligence. Artificial intelligence came to actually use computer science to do activities that were intellectually hard for us. We knew how to get done, but we didn't have enough processing capacity. The killer app was chess. How can you actually decide what is the next best move? So you actually use computer science to understand all of the possible combinations, the possible plays from you and your opponent over and over and over again to decide what to do next. Why did we choose chess? Why did we start there? Because we actually could put in very simple rules how to play chess. The board was well defined, a well-counted number of cells, pieces. We understood how the pieces moved, and we understood what took to win. So we wrote that in rules and told the computer. Then, later on in the 1960s, 1970s, but it only became viable in the early 2000s, came machine learning. And the killer app for machine learning was predictive analytics. Have you watched the movie Minority Report? This has absolutely nothing to do with it. The idea with predictive analytics is that you actually look at data over history, and you understand that when certain input conditions, like predictive analytics, for example, when certain input conditions actually happen, the device needs to be replaced. Or when those conditions happen, typically the device fails after a certain period of time. When you actually understand that relationship between input data and output conditions, you can define a model. The simplest model that you can find is a line, and it is typically called a linear regression. You try to find the line that best fits the conditions. Once you have the line, of course, then when you have new input conditions, you can kind of predict what the output conditions are, and you can replace the part before it fails. That is a very simplistic view, but that's when we actually started using the approach of learning from the data to predict and model the future. Then came deep learning, which, by the way, also happened in the 1960s and 1970s, but AI went through what is called the AI winters, and we are going to see why. It only became viable in 2012. And the idea with deep learning is fundamentally different from the idea of what artificial intelligence started. In AI, we actually knew how to solve the task, but we didn't have enough computing capacity. With deep learning, we have absolutely no idea how we get the job done, and we want to teach computers how to do that. And the biggest example is how you recognize the face of other people. I don't know about you, but I thank God I had a very, very strong mother, that when she entered the room, we could recognize her without looking, because there was not enough oxygen for anybody else. And I have to tell you that how can we express that to computers? How can we actually say how our brains work, how we create associations, how we recognize the faces of our children, relatives, and so on? And because we couldn't do that, we decided on an alternative strategy. And the alternative strategy is, if I teach the computer how to identify similarities and differences, how do I teach computers how to identify patterns, and I show thousands, millions of pictures, and I tell you, these are of this type and these are not of this type, then the computer will be able to infer the similarities. It's very similar to the game that we actually played as a child. We put a circle and we said, hey, there are 10,000 chairs here and a couple of tables, and you would ask a kindergarten, what doesn't belong? And the kindergarten would say, the tables don't belong to this circle or this set. You show fruits and vegetables and so on and so forth. So why do we care about deep learning? We care because machine learning, deep learning, fundamentally changed the workflow. And if we talk about agility, this is what is happening today. You have a data scientist whose role changed fundamentally in the last 5 to 6 years. A computer science today a data science starts today with a business problem. You want to solve predictive analytics, or you want to do face recognition or image recognition, etc. And you tell the data scientist to solve that problem. The data scientist actually researches on the internet what is the best model out there, the cutting edge technology that is being used to that, and he combines those pieces in a very agile and friendly manner. And once he actually has a model, he puts that model for training. In order to train that model, you have to feed thousands, millions of pictures, and we are going to see about that. And once that model actually gets trained, you send not only the model, but also the parameters of the model into production. This is actually called inferencing sometimes. Google calls it serving the model, and that's when you actually put in production. And from that point on, if the model doesn't give you the results that you expected, there was a failure of the device and you were not able to predict, then you actually have a feedback loop. Now, even though we are talking about 1, 2, and 3, this is not a waterfall kind of approach. It took computer science 40 to 50 years to go from waterfall to agile. AI, machine learning, deep learning is starting in a very DevOps, which is called DevML, machine learning ops, or DevAI ops, in an agile environment. And the best example of that is Netflix. If you look at Netflix, you actually have tens or thousands, dozens of models that are being served. Never when you actually connect to Netflix, you see the same recommendation using the same algorithm, because they are always testing a new one. You have hundreds of models being trained, and you have another 100 of models being designed. Now, if you take a deep dive on how you actually train a model, you have typically one of the learning approaches is to use supervised learning. So you have people that look at what is good and what is bad, labels those images, and send those images to the model. The model sees millions, trains, defines the parameters. Those parameters are served, and from that point on, when you show an image without a label, the model can say good or bad, right or wrong, yellow, red, and green. Why am I telling you that? Because that requires an unprecedented amount of data in order to train a model accurately. And where is that amount of data going to come from? From another technology force, the Internet of Things, or IoT. IoT for us, or thing in the Internet of Things, is the 3 C's: context, connect, and communicate. They have the ability to create context via the actuators. They have the ability to collect context via the sensors. They have the ability to compute, and they have the ability to communicate. And why should we care about those things? So let me tell you the story of my umbrella. Suppose that you work for a company that manufactures umbrella, and it costs $5 to manufacture an umbrella. You put the business plan together, you go to the CEO, and you tell the CEO that the marginal cost should have, you should increase the marginal cost by 10%. What is 10% of $5? I know you're not in finance, but what is 10% of $5? 5 cents, right? You say, hey, we should increase the cost by 5 cents to make that umbrella a thing. And your CEO asks, why should I? You say, hey, if an umbrella is a thing, That umbrella can now be personalized. And when Patricia buys an umbrella, Patricia buys Patricia's umbrella. That umbrella is connected, remember, to the cell phone, to the smartphone. And whenever Patricia wakes up, the umbrella wakes up. And the umbrella sees that Patricia is going to Houston. And that last night, there was going to be a very, very bad thunderstorm and rain. So the umbrella actually makes an executive decision that should go with you. And the umbrella does what anything would do. It sends you an email and a text saying, please pack me with you. Now, I don't want to carry an umbrella because I don't want to check luggage. What am I, grandma? And I don't want extra anything with me, so I leave the umbrella behind, and no umbrella should be left behind. So by the time that I get out of the door, which the umbrella knows because the door locked and I am in the car, the umbrella has what is called a digital tantrum. The umbrella beeps, shakes, blinks, lights, sends Instagram, Facebook, LinkedIn. Now everybody knows that I'm going to Houston. And I start getting requests from all the relatives about gadgets that they want me to bring with me. And now I'm really mad about the umbrella. And I said, hey, I too had children. By the way, I had twins because I believe in batch processing. And when they were 2 years old, what do you do when they have a tantrum? You ignore. You say, I'm going to teach you a lesson. If I don't pay attention, you will just get over with it. I'm not sure if it worked with you. But in any case, these are what the books say, and you apply to the umbrella. What have you forgotten here? That your children were not a thing. And because your children were not a thing, they couldn't have the 3 C's. They could not, at that age, create context. They could not compute, and they could not connect. So what will the umbrella do? Your umbrella will send a text to your health insurance company and say, should you fall sick, you should have no right to be reimbursed because you should have taken the umbrella with you. The point of the Internet of Things is that it's going to fundamentally change the world around us, how we perceive and how we do business. And the killer app is the autonomous drive. So let me tell you another story. Once upon a time, there was a car that requires a human to drive it. And that human used all 5 senses. If you have driven in Brazil, one of the best one is your touch. You have to hold to that steering wheel to know the size of the hole that you're going to overcome, and if you're going to come out alive. But we used all of those 5 senses to drive. And if we want to actually take the human out, we have to replace those 5 senses with a system of systems of Internet of Things that can be rather complex. But what happened was that when you actually put those aside, you realize that humans had a lot of limitations. We couldn't see that far. We could only see in front and around us, but not in the back. We couldn't hear all the sounds. And as a result, when we took the humans out, we started putting sensors. And as we put more sensors, we may have overdone it. And as a result, we got a 360-degree view of the car and a very, very detailed and complex view of our surroundings. This is what is called a vector space. And a vector space is so complex that in order for humans to be able to absorb, some of the details have to be abstracted away and have to be flattened. But with that, what really happened is that in trying to mimic what humans do, we got something much, much bigger. We got a vector detailed space. Which brings us back to oil and gas, and you thought I would never get there. Exploration and production is the fact that as we actually try to reduce the presence of humans, and as we try to put more and more sensors, the search, the quest that we have at play is how we are going to acquire our vector space. So I was very involved in Brazil in 2010, 2011, when Brazil found the pre-salt, which is the layer of oil below the salt layer, 7,000 meters or 7 kilometers below the surface of the water. And I was in a meeting, and the guy said, hey, I want a platform that only has a man and a dog. So I said, why do you need the dog? He said, to make sure that no man touches any buttons. So why do you need the man? To feed the dog. So when you are on that quest, you actually need to understand that the sensors have a meaning. And the meaning of the sensors is to give you the 360-degree view, to give you the vector space of that platform the same way that autonomous driving is giving that kind of analogy. And it will give you the breadth, the height, the depth, the far depth, because those platforms are going to be able to talk to each other and create a much more richer context. So this is the first point of advantage of IoT, is this notion of dimensionality, that you are going across for dimensions. The second one is that with autonomous driving, now you have a duration of time on everything that is happening across the vector of time, and you want to do that not only for a given platform, but also do that across all the stages of the oil and gas workflow pipeline, which is the second D, the duration of time. And the last but not least is the fact that in AI, the model learns what you teach the model. So suppose that when you actually learn how to drive, you have to learn how to drive in a highway, in a suburb, in a city. And maybe the best places in the US to learn how to drive are, if you want a highway, go to LA, where you have a 5-lane highway that is in a traffic jam at 80 miles an hour. Then you also have whatever area you call Florida, where I'm told that Americans go to retire. And there you actually drive cars that are 5 meters long and at 5 miles an hour. And then you have New York, that's where I live, where you have a city that was designed to drive horses and carriages, and now not only you put cars, but you put millions of people, if you can call them, distracted with the mobile devices that are everywhere. They are the reason for traffic. So now can you imagine that you train an AI model in California, and now that car finds itself in Florida. Will that car know how to drive in Florida? Some people say the average expectancy life in the US may go down because there is going to be so many disasters, so many accidents that you are going to get lost. The point is that those sites that are doing AI, they will need to learn from the local data, and they will need to be able to exchange that knowledge among themselves to have a model that has the combined wisdom of all the models together. And that is not only continuous integration and continuous development, but also continuous learning. That's what we are advocating. The fact that models are trained in distributed, disparate ways, and that those models communicate to each other, they exchange parameters of the model, and they build strong, more resilient models. IoT gives you not only the 3 C's, but also the 3 D's. Dimensionality of data, duration of the data, and the diversity of the data. Once that analytics gets created, it will be absorbed via augmented reality, virtual reality, mixed reality. It will be blended in on the natives of the digital universe, the robots, and because there will be the need to process those AIs, there comes the accelerators. Remember the training that needed to be done? You have to feed millions of images in order to learn and train the model. Well, when we had the CPU, that training needs to happen by feeding those images into training the model, not only once, but twice, 3 times, 4 times, too many times. Every time that you actually feed all those images to the model is called an epoch. You train the model once, you look at how accurate the model is, and if the model is not accurate enough, you adjust the parameters and you train again. And once we actually started doing that with CPUs, we realized that a Swiss arm tool, such as a CPU that can do any type of instruction, was not as good enough to do the kind of processing that you needed with AI. influenced by the gaming industry and by all the augmented reality and virtual reality experience, then the graphical processing unit, which started in gaming, was adjusted and adapted to also do AI and machine learning. Now you have servers that are hybrids, that are heterogeneous, where you have CPU and GPUs. The CPUs are now called the hosts. The GPUs are called the devices. A GPU alone can do 100 teraflops, or terafloating operations per second. They are typically arranged into 4, 8, or 10 GPUs on a board. And now you can get massive computing power. These GPUs are not the only kind of specialized processing. The overall class is called accelerators. They manifest themselves in FPGA. Also, Google created the Tensor Processing Unit, or TPU. Tesla has its own, and so on and so forth. And as a result, processing power is everywhere. Do you know the song, Who Let the Dogs Out? Inspirational. I have read that lyric to find the point, and I kept scrolling, thinking there was something else. No, it was all of it. So I created my own version. Who let the course out? This is the fact that all the processing power, which was under our warm control, motherly control, fatherly control in a data center, has spread everywhere. And as that processing power created sprawled everywhere, we actually find the moment, the right moment for AI. I don't know if you remember, but when we started this presentation, AI first started in the 1950s, 60s, and 70s, and it had AI winters. And why it had AI winters, and why is AI only, the time for AI has come now? Because of those 3 conditions that have come to age. Number one, the models, the deep learning models and the machine learning models that we created are much more sophisticated. That's the vertical axis. You have tools and frameworks that allows you to combine many layers. Models today have between 140 to 200 layers. Second of all is because of the data posture that is now available with the Internet of Things and many other data sources. Remember the duration, the diversity, and the dimensionality. Once you have more complex models and you have a database to train that model, now you need more computing power. And with the idea of the accelerators and with the economics of the cloud, you have the 3 conditions that have been met. And that's what we call at Dell Technologies the unreasonable effect of scale, or the unreasonable effect of cloud scales, of continuous scale. And that led to what is called the cloud continuous. When the public cloud came along, we thought that cloud equated to public cloud. But then we soon learned that yes, public cloud meant that you need to have some infrastructure on your private data center that you could consume from someplace else. But you also learned that cloud was much more than public cloud. What public cloud gave us was a set of principles, a set of fundamentals that we call the cloud economics. And they are around the idea of scalability, extensibility, agility, and so on and so forth, consumption, different consumption models, service catalogs. Once those cloud economics, which started in the public cloud, those principles applied to your private data center and became private clouds, they are now propagating to the edge, creating the edge cloud, and they are also propagating to the telco, creating the telco cloud, and the applications that you buy as a service have created the SaaS cloud. For us, that's the entire cloud continuous that goes from the edge to the private, to the public cloud, across a telco, all the way to a SaaS. And that's the cloud. Now, once you had those cloud economics, on top of a cloud continuum, you had the emergence of cloud-native applications. Cloud-native applications are fundamentally different because they are far away as possible from our monolithic ancestors. And they are actually broken into pieces, microservices, they are decoupled, API, and I could bore you with 10 not 12, of the properties of cloud natives. Why do we care? Because out of a sudden, the world was divided into the traditional applications and the cloud-native applications. And even though the cloud-native applications are different to develop, they are different to operate, and the change is always hard, yet there is an exodus of all of the traditional applications into a cloud-native mode. And the question is why? Why are they moving from here to there? Because cloud-native applications also have a set of 10, if not 12, benefits that they give you that were not present in the traditional application. And those benefits are going to fundamentally change the economics of your business. So as with any move, suppose that you have lived in your house for 40 years and you decide now to go someplace else. You look at everything you have and you say, I'm going to not need some of those things as I move on. So these are the applications that you decide to retire. Some other applications you say, I am not taking that with me because I can buy in a different way when I get there. And those are the applications that you're going to repurchase. Those are the applications that you do as a service. But then you have very important applications that run your business that are differentiated, and those applications you wanted to refactor or rewrite or rebuild. Some other applications you are saying, it's not worth the effort, but I'm going to put in a container. That's what you call replatform. Other applications you just want to virtualize, and that's what you call rehost. And some other applications you're saying, I'm just going to retain and let them die for natural causes. In order to decide which application belongs where, you actually use a graph. And you say, let me take a look at the business differentiation. That's the x-axis with the highest business differentiation going to the right. And you say how hard it is for me to go cloud native. And the easiest one, the ones that are closest to cloud native, is the y-axis. And then you say, if I have no differentiation here, and it's very hard to make it cloud native, just retire. If I have a high business value, but and it's a low business value, and it is very close to a cloud native, those are the ones that you repurchase. Salesforce.com, Workday, HR, applications, and so on. For the other applications that have high business value and are very close to become cloud native or can become cloud native easily, these are your low-hanging fruits. This is where you want to refactor immediately. But regardless if it is easy or not, if it is a high-value application, that's how you differentiate, you will need to refactor and make it cloud native. You can start with the easy ones and go all the way down, but you have to do it anyhow. And for the other ones that have a mid-business implication, and depending on how easy or how hard it is to go cloud native, you decide whether you are going to replatform, where you are going to rehost, or where you are going to retire. Regardless of where the application lands, you have to make sure that those applications get deployed into leveraging the cloud economics. And where they will land? Across the continuum. And that's how the future looks like. Now, let me go back to the forces. As you create a continuum, 5G becomes ever so more important. And once you have 5G, you also need blockchain, because as your environment becomes distributed across the cloud continuum, you need to make sure that you know who is doing what to whom. And even though blockchain has been equated with cryptocurrency, the fundamental technology principles of blockchain, of a distributed ledger, exist forever. And once you have all of those technology forces, now you can have very vibrant active markets. The best example of the active market that we have is Uber, Lyft, BlaBlaCar, and many others. But look at the pattern. You have an asset, in this case a car. You have a marketplace where you can trade things, and you have actors. And I put the actors into 4. You can own a car, you can drive a car, you can become a passenger, or you can become a payer. Once you have actually that model, then the steps to create the platform are very easily. You create a platform, you attract the actors, and you transact the actors. Once that is in place, now I can replicate that to other models. What is the best replication of the Uber, Lyft, or mobility sharing services? Hospitality sharing services, where you have Airbnb. And once you have that concept, you can take it to any kind of domain and change it and apply. So I wanted to actually leave an idea here with you. Suppose that the type of asset that you have, instead of being a house or a commercial space like WeWork, is something else. What if the asset that you actually have is data? So let's change the car for data. Let's change the marketplace and call it an analytics sharing services. You're sharing the analytic results of the data that you won at a price. Then the players, you call these you find a new logo. And the players, instead of the car owner, you have the data owner. Instead of the drivers, you have the data scientists that are actually harvesting value of the asset you have by offering services. Then you have the buyer, which is the data explorer, and you have the payer, which is the business. And that becomes a complete new market, that instead of trading physical assets, you are tracking digital assets. And the technology forces will not stop there. Quantum computing will come, and many others. And as we are lost in thoughts, I want to be lost in thoughts, some final thoughts. The moment you thought it would never arrive. The future is going to be defined by technology forces, and it is going to be bound by technology forces. And in this future, there is going to be three types of people. People that make it happen, people that watch it happen, and people that do not know what the heck happened. As you are in this digital era, what are you going to be? What are you going to do? Are you actually going to take a picture of the world as it is today and make it digital? Make everything that you see around you eternally lasting because you automated it all? Or are you going to become an explorer of those technology forces and use technology to graph, to design, to draw your future, our future, far beyond artificial intelligence towards artificial genius? Together, only together we can change the world. Let the digital transformation begin. Thank you very much. Enjoy the day.